5 minus x 8x to the power of 3 plus oh fuck my life. Okay. cut cut how did I turn this shit off? Christ. Hello people, welcome to the fourth video for our lecture number 4. As I told you already, I decided to kind of change plan for this one, so I will, instead of making one video for entire differentiation thing, I'm gonna do 2 vids so that actually you get it, that you get 2 shorter vids, and then also it's not overloaded with information. So that being said, first video, which is this one, we're gonna focus on differentiation rules. We're gonna take a look at the first derivative and then also second derivative, and that would be everything for the first video. So let's dig into it. So differentiation rules. I'm presenting this as a table. There are examples that we're gonna go through them immediately, so I will not talk much about this table right now, but the most important thing is that you know that there are 5 basic and most popular, let's say, rules. Constant power, product, chain, quotient. Of course there are many more, and the other rules are shown in our little cheat sheet, so you don't need to memorize these 5 rules or any other rules. Never ever. You just need to be careful and to be able to actually see which rule applies for which function. And now we're gonna go through each one of these rules real quick. So basically, how do these rules work? First one, let me zoom in. Okay. So the first rule, constant rule, when our function is a number, any number, when we differentiate it, we will get 0. So what does it mean? Let's say we have function f of x equals 8. F prime, which is just the first derivative of the function, will be equals 0. So this is how we write the first derivative, by the way. It's just a little line here. And yeah, that's for the constant rule. The power rule, it's when we have x or any number in front of x to the certain power. And then when we differentiate it, the power that we had here will come in front of the x. And then what will still stay as a power is the number that we already have, minus 1. So what is it going to look like? Let's take a look. The function of 3x to the power of 5. When we differentiate it to the first derivative, we would get 5 times 3 being equals to 15 times x to the power of 5 minus 1, which will give us 4. That's pretty much it. Product rule. Okay, this one is a bit longer. So product rule, as the name says, is just a product of 2 functions. So when we have a function, let's say h of x, is given as product of 2 different functions. So f of x times, this is times in my computer language. So f of x times j of x. G, sorry. And when we differentiate it, what is it going to look like? First derivative of f times g plus f times first derivative of g. So let's take a look at the example and it will make more sense. So let our function h of x be equals negative 2 times x to the power of 4 minus 3 times negative 2x to the power of 2 plus 1. So what are we going to do? First we're going to separate our functions. So first we have our function f of x, which is negative 2x to the power of 4 minus 3, and our function of g, negative 2x to the power of 2 plus 1. we're going to find first derivatives for each function. So the first derivative of function f will be negative 8 times x, so to the power of 3. If you recall, this is actually our power rule, which we just finished like 3 seconds ago. And then for g, we're gonna have first derivative to be negative 4x. And now we're gonna multiply them by multiplying f of x times g prime, or g derivative of g to the power of x, and plus f prime to g. So what is it going to look like? Negative 4x times negative 2x to the power of 4 minus 3 plus negative 8 x to the power of 3 times negative 2x squared plus 1. When we multiply it, we will, and kind of simplify it, we're going to have that first derivative of function h will be 8x5 plus 12x plus 16x to the power of 5 minus 8x to the power of 3. When we further simplify this, we will get our answer, which will be that first derivative of the function h is equals 24x to the power of 5 minus 8x to the power of 3 plus 12. And that would give us the answer to our, actually it would give us the first derivative of our function h of x. Now we're gonna take a look at the quotient rule. So how would we recognize the quotient rule? It is basically function dividing function, okay? And when we have something like that, we would find the first derivative of the function h of x by first finding derivative of the function f, so, and multiplying it by the function g, unchanged, then minus unchanged function f times first derivative of function g, and it will all be divided by function g to the power of 2. So let's go to the example to make it look more easy. So we have h of x being equal 3x to the power of 4 plus 2 dividing 3x to the power of 3 minus 2. So as we did in one of the previous rules, we're gonna just separate this and find their derivatives. So here we have a function f. Our first derivative of the function f will be 12x to the power of 3. Then here is our function g, and then the first derivative of our function g is 9x to the power of 2. We're gonna cross multiply them. So we'll have 12x to the power of 3 times our g, which is this, minus, don't forget that minus, please pay attention to the sign, minus 9x to the power of 2 times f. And we would divide the entire thing by 3x to the power of 3 minus 2 square, entire thing, which is basically our g square. And then when we multiply everything, and when we kind of simplified it, we would get to the answer that first derivative of function h of x will be 9x to the power of 6 minus 24x to the power of 3 minus 18x to the power of 2, all divided by 3x to the power of 3 minus 2 all to the power of 2. Of course, you can solve this one. It's totally correct. Even if you solve it and then just like so that you get rid of this actually 2 and then you have like entire function, is totally fine, but it's also acceptable if you just leave it as this. Okay, we're gonna go to our chain rule. So what does the chain rule looks like? It is if you have a function in function. Okay, so this sounds complicated, it's not, trust me. So when we have f of g of x, we would differentiate it by first finding derivative of this f times what we had inside times the first derivative of inside function. So what would it look like? Let's take a look. So let's say that our h of x is 3 x to the power of 3 plus 3 all to the power of 5. So this is our function in a function, because this parenthesis could be also written as x. Okay? And in this case we would use our chain rule. So please be careful, do not mix this with other rules that we've covered. This one is, in my opinion, the trickiest one. So let's solve it. So the first derivative of h of x will be 5, because of the power, it's coming in front, right? 5, and then our j, it stays the same, it doesn't change for this one, so we will just rewrite it x to the power 3 plus 3, and then we change, of course, our powers. We learned it like 20 seconds ago. It will become 4, because 5 minus 1 is 4, times, and now the first derivative of what we have in the function g, so it will be 3x to the power of 2. Then to find the answer we would just multiply this 5 and 3x to the power of 2 to get the as simpler solution as possible. Of course you can try other ways, but this way is the most correct one and it's the fastest one. So we would have that our answer is 15x to the power of 2 times x to the power of 3 plus 3 and the entire brackets to the power of 4. But now you have to be careful when you're solving the exercise. Sometimes you will get the exercise that requires more than one rule to be used, and that's really common, especially on the exams. So let's take a look at one example. So h of x is equal log of 4x minus 1 to the base of 2. So which rules would we apply in this case? Always when you have it, always come back to your formula, always take a look at there, you will find the answer for sure. So in this case we would use logarithmic rule, which we have in our formula booklet, and the chain rule, because it's function in a function. So it's a function in a function, because this log of this function could be also written as log of x to the base of 2. And then we would use, as I said, our logarithmic and chain rule in order to solve for this one. So what would it look like? So first of all, I just copied the chain rule here. You already have it written in the table and also where we looked at examples. And then this is just from our formula booklet. So f of x to be equals log of x to the base of a will be differentiated by 1 over x times ln a. So let's take a look at and see what would it look like in our case. So first we would differentiate for log. There we would have 1 over our x, and our x is, in this case, is 4x minus 1. So 4x minus 1 ln 2, so why 2? Because 2 is our base, times 4, which would be just, when we differentiate the brackets, we would just stay with 4. And then, really simply, this 4 comes here, so we would say that our answer is 4 divided by 4x minus 1 ln 2. So please just be careful. When it comes to these solving derivatives, this is the hardest possible. So there's nothing much harder. You know, you can just get different rules to work with. So please, when you get the equation, when you get the question, just slow down, really take a look at your formula booklet, on your exam paper, see what you're supposed to do, and then just do it. It's really simple, trust me. That's pretty much what it is for first derivative. Now we're going to take a look at second derivative. And what is second derivative? So the second derivative is just the first derivative of the first derivative of the function. So it does sound complicated, but trust me, it's not. All the rules that we've covered for the first derivative also apply for second derivative, for 10th derivative, for 17 derivative, doesn't matter. Okay, all the rules are same no matter what derivative you're looking for. Okay, and now let's take a look. The notation is different. We had our h with apostrophe here, then he will just like have little quotation marks that you can write here, and that would be just second derivative. And what would it look like? F of x to be our initial function to be equal to 3x to the power of 5. So to find the first derivative of this one, and we already know that because we've done it, so the f prime of x, I'm sorry, will be equals 15x to the power of 4. And now the question is find the second derivative. Easy. So this 4 comes in front, so 4 times 15 will give us 60. X to the power of 4 minus 1 will give us 3. It is just a simple rule that we just covered right now here in our which is our power rule. And that's it. I will not talk about second derivative any further because I already spoke about first one. If there are any questions, guys, regarding this, please call me. This was our first part video, and I will see you in the next one. Stay safe.